The graph of a function can be transformed by either sliding, stretching, shrinking, or reflecting. The elementary transformations of a function f are captured in function notation as follows. Translation. Sliding up or down is given by f of x plus k. Sliding left or right is given by f of x minus h. Distortion. Stretching or shrinking vertically is given by a times f of x. Stretching or shrinking horizontally is given by f of b times x. Reflection over the x-axis is given by negative f of x, and reflection over the y-axis is given by f of negative x. Sliding or shifting the graph of a function f of x up or down is given by f of x plus k, and is called a vertical translation. If k is greater than 0, then the graph of f of x slides up k units. If k is less than 0, then the graph of f of x slides down k units. Consider f of x equals x squared and two of its translations. We have g of x equals f of x plus 2 equals x squared plus 2, and h of x equals f of x minus 3, which equals x squared minus 3. The graph g is the result when f slides up 2 units, and the graph h is the result when f slides down 3 units. Use the function g of x equals absolute value of x for each problem below. Write a rule or formula for the new function after the given translation. Slide the blue graph up or down as described. Alright, so this red graph is absolute value of x, and this blue graph is the absolute value of x plus k. So we're going to move it up 3 units so that it is absolute value plus 3. So this is the absolute value of x plus 3. Now we're going to move it down 1 unit from the red graph, and we have the absolute value of x minus 1. Then we can move it down 4, down to here, and that is the absolute value of x minus 4. And we can also put it up here, and that would be the absolute value of x plus 2. Use the function f of x equals x squared plus 2x for each problem below. Write a rule or formula for the new function g of x after the given translation. Alright, so right now we have the same graph. We have x squared plus 2x. Now we are going to move it up 1 unit to there, and that is f of x plus 1, which is x squared plus 2x plus 1. Then we can move it down 2 units, 1, 2, and that would be f of x minus 2, which is x squared plus 2x minus 2. Now we can move it down 5 units to create, way down here, we have f of x minus 5 equals x squared plus 2x minus 5. And then finally up 3 units to create 1, 2, 3, x squared plus 2x plus 3. Let f of x equal 6x minus x squared. Its graph is displayed on the right. The function g is given by g of x equals f of x minus 6. Carefully sketch the graph of g of x on the grid to the right. Label at least 3 points on the graph of g. Alright, so we have f of x minus 6. So we take our point, like the vertex, and that's at 9. So we subtract 6, and we draw our new point here. Here's another point at 0. So our new y-intercept will be down at negative 6. And we can mirror that point over here. So we can move this point down 6 as well. And we have our new graph that looks like that. Write a formula for g that does not involve f. Alright, so we have f of x minus 6. So instead of f of x, we can write 6x minus x squared minus 6. And that becomes negative x squared plus 6x minus 6. So we have 6x minus x squared minus 6. And you can see that our graph looks a lot like what it's supposed to.